Welcome to the session on the demonstration on metal additive manufacturing. I believe that you are now well aware what is additive manufacturing. There is a file that is a CAD file. We convert that file to the STL format, and layer by layer we try to develop the build or the body or the object that we like to produce. So with additive manufacturing is in various forms. It could be polymer, it could be wood, ceramics. Metal additive manufacturing has now taken new leaps. There are certain printing companies, printer developing companies, like 3D Systems is there, Ultimakers is there, Mark4 is there, those who have developed multiple kinds of metal 3D printers. It depends upon the size of the print that you like to have. So the size of the printer that it can hold is known as work envelope. What is the maximum 3-dimensional size, X into Y into Z, it can print. More important point is the sinter. Before that, I'd like to tell you there are 3 major components of the printer. One is we do printing. In printing, the metal comes through an extrusion nozzle. It is in the form of wires here, the filament. So it is printed, it is melted, and then the metal the object is printed. After the printing, there are certain support material, impurities which are not required in the final component. Those are to be washed. This is done through a washer. Third component is sintering. Sintering is when the component is obtained from actually printing, it is a green component and it is too fragile. If the component falls or so, see, it might even break. So it has to be now heated to the specific temperature depending upon the material. There are certain material, we have stainless steel, copper, inconel is also coming. So many materials are available. A big range is developed by our supplier, it is Mark4. So they, depending upon the kind of the material, you people might be aware of the processes like annealing, because we have to slow down, we have to heat the temperature to its critical temperature. Then it has to be slowly cooled down so that it solidifies and it becomes a total solid and the usable metal material. That component for that machine part is known as sintering. So let us now see the printer. This is metal 3D printer, which is Mark4 make printer. Mark4 is one of the pioneers who is working in now even multi-jet printing. When we say multi-jet printing, the printers might even overshoot the conventional machining methods. The only drawback, major drawback in the additive manufacturing is the process is still known to be slow, because a single nozzle, it has some limit that up to maximum speed, but it can go and it can build the material. So when we have multi-jet printers, multiple jets would come and try to print them in one loop. So then it will become easier and faster for the printers to print. Cost is another factor that is also being worked upon by many of the developers. So let us now see the printer that we have. This is the printer, metal 3D printer. This is the washer I just talked about, and I also have a sinter. We will come to that. So in this printer, there certain recommendations are there and certain instructions are there, very important instructions before using the printer. The major operations, I would say, we have to prepare the bed for that, we have to prepare the material, we have to vacuumize that. What is the purpose of vacuum? So that there is no impurity, no gases, no voids available left in there, so that we do not have any kind of the defects in the final build that is made. When I say build or object or by that I mean the final print that I am trying to make. Right? So let us now see closely the components of this printer. This is the full box. It has an extruder setup. It has a bed. This is a work envelope. So we can just see the two filament spools here. So you can maybe control also. So the two spool holders, I would say, two spool holders are there. We have, this is the metal spool through which metal filament is coming. Right now what we have held here is a stainless steel. The stainless steel is specific grade of stainless steel is developed by this company. When I say specific grade, they have developed full parameters for this. Parameters means what are the parameters to control the temperature. So what if, depending upon the thickness of the walls, depending upon the infill that we have in the material, depending upon the density, depending upon the print size and angles. So all these parameters are to be optimized by the company when they supply this material. So this is a filament, this is what stainless steel, and at certain times, because metal 3D printing suppose this kind of print is to be built, it has to have supports in between, because this is a cantilever kind of a beam which cannot be held in air, so we have to build certain supports so that it can maybe build this thing. Fine. To remove these supports, so that these supports doesn't become the part of the made print, we have to put some coating in between, so that it is removed easily. When we put it into the washer, certain support materials are removed from that, or when we after the sintering should remove. For that, a certain parting material is used, that is our ceramic. So both of these spools, the software understands what is the shape of the print, what is the size, and what are things which we are doing, it takes accordingly. Now this is the major, I would say, spool and the extruder setup at the top. I will show you the extruder now. So this is an extruder, the extruder of the printer. The extruder has, you can see the two inlets which are coming up. So the most important part in extruder is the extruder nozzle. I am opening the door of a printer. There is a green part we already run for you, because to print in front of you, if I say it takes several hours, maybe the hours are of the order of the tens of hours, maybe 20 hours, 30 hours. At time it is, if it's a small print, it might take 5 hours or so. So this is a green part that is ready. So technically, or according to the instructions, if I say I should not touch this with hand. Right now it is not that hot, I have touched it. There are ways to pick, we'll show you all the tools as well. So this is the extruder. Most important point is the nozzle. The precision, I would say, or the resolution, that is the minimum feature size that we can get in the print, depends upon certain factors. One of the major factors is the nozzle dia. Because what is the nozzle dia? Only that kind of the thickness of the material coming out would come, and that also determines your precision. Fine. So this is one of the components we have shown. So let us now show you to set up the printer.
This is the closer look to the display of the Metal X 3D printer. So in this you can see it is showing 17.4 stainless steel is loaded, ceramic release is loaded, these two filaments are loaded here. Then you have, they say the print bed is ready, that is, it is hot and it is ready, and the vacuum is off as of now. So let us see these options which are available here. You can see three icons at the top. There is a black bar at the top, there is a blue bar down there. In the blue bar they are asking updates are available from the previous version that you had, and on the black bar it is showing three icons. So these three lines, if I click here, it will show the menu. In this menu we have manual control, materials, storage, utilities, print queue and settings. These 6 options are here. So how to connect this machine online using Wi-Fi, so all these things could be here. Then we have this other button, that is the network manager. In the network manager, options are Ethernet, that is using connecting a bus, or Wi-Fi, or I believe we should use it offline itself. So at this point of time, so it was at Ethernet, so we have clicked Wi-Fi now. So it is showing the ITK internet connectivity is there. You will see done. Now it is connected using Wi-Fi to the internet. So if the internet is not connected properly, so it won't work. So this is connecting to Wi-Fi. This is one of the steps. So again, let us come to menu. We have these 6 options here. Let us see what settings are available. In the settings, if you see, it is showing the network manager, update manager, security, system info, temperature dashboard, and errors or any debugging if it is required. So let me click the system information. So let us click the left bottom option, system information. This is our touch screen. In the system information, you can see the print information, the release date, the firmware version. It is showing what is our system and when is to be this updated next. Sometime after it shows that. Now coming back to the main menu, using network manager we generally connect to the Wi-Fi, Ethernet or so. Next, second option is update manager. In the update manager, it is asking whether you wish to update the system. There is a cloud update available. USB update is also one of the options. So once the update has started, do not shut down or unplug your printer. So there is a message here. So USB would mean we have downloaded the update on a USB, then we connected USB to the printer. So some errors if those come to in update, it also say okay, the update is not proper, the update is still required. It will keep on giving those messages. Again, coming to the main menu, settings, update manager is now okay, somewhat touched. Now let us see next is utilities. In the utility, 5 options are there: bed level, maintenance, print, head alignment, network diagnostics, test prints. 3 options are there which could be done, which could be taken care of using the screws down there in the bed. So we can select please remove the print sheet from the bed, because before setting the bed level one has to remove any setup if it is there. So we cancel it as of now. We'll say done. So it has come to the main menu once again. So all these options have different sub menus in them, and in the security, if you wish to see, we can change the access key. System information is done. Okay, next is temperature dashboard. So temperature dashboard is showing the bed level, the meter hot end, the release hot end. So all these temperatures which is right now there, it is showing it here. Again the menu, settings. Now errors. In case some errors come, those are to be cleared, then we have to come to the error tab here and try to work on that. Let us come to the manual control, which is mostly used. So print bed, metal nozzle, release nozzle, lower bed, home bed, these options are here. Now materials, either we can load or unloading materials, reset the metal meter, load release, unload the release, and reset the release meter. So if something is, some material is stuck, so how to start from there, how to start or load the filament spool back there. So all these things could be taken care of using this menu table. So to load material, it will be showing now the, please select the loading option, quick load, meter load, or same spool. The spool is already going or working, so it is stuck for some reason, so we can say same spool has to be continued, then it starts working. If the spool is consumed in bit, then we quick load it and try to start the same spool. The meter load is we try to measure the spool and try to load it, the new spool. Unload also has similar options. So when the nozzle is chocked generally, then unload method is used. We have to unload and the nozzle cleaning has to be taken care of using the small hard tools which are available for cleaning. So now there is a option storage. So this is for storing the systems. In the print queue we can also see whether something is already there in the queue and how long would it take. It is right now so nothing is in queue. So setting the bed level, number of screws in the bed and positions of the screws, and how to label the bed using the screws and using the options here available in the display menu of the printer. All these things could be seen. So let me come back. Home. This is the home window of the display. So what is loaded here is once again 17/4 stainless steel as the main print material, ceramic release for the parting material wherever the supports are to be removed, So let us now come to the main printer volume here. So if we come to the manual control here, it is showing print bed, metal nozzle, some options are being shown here. A home bed, if I click home bed here, it will try to do homing for the bed. Homing for the bed means it should try to bring bed to a position and try to see whether the nozzle and the bed could work to all the extremities. So to the extreme X, extreme Y, extreme Z, it will make sure that the machine is working properly. This homing is generally one of the processes or one of the starting process of starting tasks that is always there in a CNC system. This is also a kind of a computer numerical control, but additive manufacturing system. So XY was all checked, XY it was checked, then now Z axis is being confirmed for the working to the extremities. For example, the volume for this printer, if it is X, Y, Z, in the Z direction, it is now checking. So it is making sure that the nozzle tip touches the bed. In the screen, it will now display as operation completed. That is, the bed has now come to the upper position. So there are screws down there, which we just talked about. 3 screws are there. So using the torque wrench, we can adjust the screws if the bed is not leveled properly. So this is a manual setting for leveling the bed, right? This is what is homing of the bed. Now it is now coming down back. It will come down to the base position where the vacuum could be created. That means the preparation of the bed has to be there. For the preparation of the bed, the temperature of the bed has to come up to the print level so that the print could be started here. So bed has come to the low position now. We can stop it anywhere, wherever we find it appropriate. You can see small serrations here on the bed. A small, I would say, grid is there in which the holes are there. That is for the use of creating vacuum there. So vacuum on and off could be done on the screen. So if I say vacuum on, the holes will try to pull the air from there, and this sheet will be attached or fixed to the bed using the vacuum only. And then this sheet won't move just like it is moving right now. Once the vacuum is generated, this sheet will be fixed and it won't move. But this is the head of the extruder, in which 2 filaments are there, ceramic in the white color and SS in the silver color. So this is a cap. If I open this cap, you can see something here inside. So on the both sides we have extruders here. So there are separate extruders here for metal and for the ceramic. So we can unlock and unload any of the material if required. We can load and unload using this. So we have nozzle down there. So nozzle helps us to extrude the material, and we have the heaters here that melts or fuses the material. So like certain materials, copper, Inconel, SS, nylon, all these different materials are being used or could be used using Metal X printer. So along with this we have tool steels like A2, G2. Then we have lower tube housing here, then upper tube housing here. So lower tube housing, if it is to be changed, then this part could be opened and housing could be changed. These all options are available here. So this is all a hard setting or maybe maintenance and repair of the printer. But this is the print head. I won't say extruder, actually this is the print head. Extruders are the parts of the print head. So this is the complete print head. To have a closer view, so two extruders are there, one for the ceramic, one for the metal. The metal in this case is 174 pH, that is stainless steel, right? So this is how the printer looks from the inside.
So now we are again back to that position where we will show you how we open the printer, how does the operation start, and the steps in that. The first step is creating vacuum. Vacuum is very important so that the layer, this material, gets stick to the plate. So he has opened the window now. Now we'll show you the display for the printer. Now this is the brush. This is a polymer brush. The polymer brush that is used to clean the printer. Printer cleaning, this whole process is known as printer preparation. In printer preparation, the first step is the cleaning of the printer for any impurities, for the last print that has happened, or maybe some dust might have come. The printer is recommended to be kept in a closed environment. So we have air conditioned environment, 25 degrees room temperature, everything is set right here, but still it is to be cleaned. So now we have put the paper that is given by the manufacturer itself. So now we can see the display, but he is clicking on the display. So it is showing the material that is there. The material right now is 17.4 stainless steel. So it is showing certain options that material, yes, material is loaded. Ceramic release, yes, it is loaded. The print bed, it is hot, that it is ready. The vacuum, it is not yet set. That is what we are trying to do now. So print bed hot implies the print bed has to come up to temperature of 50 to 70 degrees. So print bed, so that the print is easily removable from that. So that is the temperature of print bed. And the temperature for the nozzle, I have already told, it goes up to 240 degrees. Depending upon the material, the temperature would be set. When you say 17.4 stainless steel, that is already entered in the software phase here. So we actually have three steps. One is the machine, that is material that is working with the printer. Second part is the software. Third part is the print. So in any of the manufacturing, there are always three, any of the CNC or computer involved manufacturing, there are three major components: the machine, the computer, and when I say computer, that is the software. Third is the final tool or the print or the job that is being done. Okay, so now we'll set the vacuum here. Yes, it is clicked, and you can see the sound. It is giving a warning that make sure that the area under the print bed is clear of all obstructions. Click next to load the print. It says that there should be no obstructions. Now they will put the print plate over it. We say next. This is vacuum plate actually. Vacuum plate has certain weight and it is completely flat or secured with the surface. So this, by help of this weight, it will now attach the paper to the surface. Sometimes it doesn't accept it once, we have to maybe try again. Done. You can see it showed the button is done. We have clicked that button and the vacuum is also ready, it is also green. Now this is now print bed is ready. It is now set there. The paper is set there and the print bed is ready for the print to start. It has already shown that yes, your nozzles, if I say the stainless steel is loaded and the ceramic is loaded, that means the filament and nozzle, everything is ready. We need to be a little assured that the printer, the filament material of the printer, the amount of the filament that is there should be enough according to the size of the print that we are going to create. So the printer is now ready to get the print command from the software. Now before we go actually print the command, I just like to show you certain tools, just certain things which are available. It looks like a simple injection. This is used for lubricating. It is having 1 mm syringe hole here. It is used for lubricating and lubricating of what? Lubricating of the lead screw or the components that helps the print nozzle to move. I would like to also tell you that the nozzle can move in X direction, Y direction, and Z direction. The overall system that is holding a extruder moves. The printer precision is better in X and Y directions always. In the Z direction, the precision of the resolution is lower. So wherever we need more precision or more closed features or small features, that orientation of the print is always put in X and Y direction. For example, if I need to print this injection itself, if I need better resolution on this side, but on the height side, I put it in this direction, because in X and Y direction, the resolution or the precision will be better. In Z direction, the precision is little lower. So this is one tool. Yes, okay, anti-seize. Whenever we close the frame, this is an anti-seize material that we put on the tip of the nozzle, so the nozzle doesn't clogs. So it is anti-seize. The name itself tells that it doesn't let the nozzle to seize or clog there. There's certain nozzle cleaning tool as well. These are copper brushes. So these are known as wiper brushes. These are used to clean the nozzle. Clean the nozzle for the ceramic and the metal both. Yeah, we have this torque driver. This is a torque driver that is used to close and open the nozzle. It is a torque based driver. Depending upon the number, when we click it, when we rotate it, we hear the sound of click, tick, tick, tick. It will deliver the similar or the proportional torque to the nozzle. How tight do you need? For it is recommended to have a single click to tighten the nozzle. But these are certain major tools that I am showing you. There are multiple tools are there. When the printer comes, it comes with a big box. Actually, when this printer was received, it was a big loader, big 404 truck. And a big nozzle was there, big loader was there, and also we have maybe if you clean the nozzle, these pins are there. So many things are there. So now we will try to put the print over. So now let us consider that the print is ready. We have set the vacuum, the printing started through the software itself. Software gives a command and the nozzles in the extruder start extruding the material, both of them, the print material, that is the stainless steel in this case, and the ceramic. So now the print is ready. Now we will remove the print from the printer. Print is ready and also it is cooled down. We will remove the print and take it to the next section, that is the wash section. He is removing the print while wearing gloves. Now he is taking this print to the wash section. You can see mark for wash 1. Wash 1 is the section that you have. He is wearing mask. Why? Because wash has two major sections. One is a dry section, one is a wet section. Wet cleaning is done through a chemical that is known as Opteon SF79. It is a liquid that is put. In that wet section, this component is left to be dipped to be completely soaked for several hours. Depending on the material, the time is decided. It has this Opteon SF79, that is the liquid. It has NPB, that is N-propyl bromide, then PERT, that is perchloroethylene, then TC, that is trichloroethylene. So the mask is to be worn and the gloves are to be worn so that it is safe for the use. This is a basket and he is holding to the basket from the basket holder. He will now keep that material. Yes, just let you know that how the basket is held. He will keep this material that is ready green very carefully, it should become, because it is too fragile. So the one has to be expert, very slow, patient. Now it is dipped into the liquid, the cleaning liquid. This is the wet portion. Please close it. Now from the now this it will be kept for several hours. After it is kept, the display will show that yes, it is done. We will set it. We are not setting it right because we are not doing it. It involves so much of use of the material and the cost and so. So when he will remove the material. Suppose the material is now washed. It has taken several hours of its process. Now it can move to the dry section. We remove it. This is after several hours, depending on the material. We remove the material and put it in the dry section. Wet section part is over. Now he'll put the material in the dry section. That will dry the material and make it completely ready to put in the sinter. Now what has happened in the wet section, all the ceramic, all the other impurities, the voids, they have removed everything. These gloves are only required for the wet section only. So those are removed now. Now the material is put in the dry section, and again depending upon the material type and the size and the build of the material, there's certain time that is fixed after which the material is removed from the dry section and it is put in the sinter. Now we'll move to the sinter part. Now consider that the wash has completed its process and the material is ready to now be transferred to the sinter. So we have kept the print outside. There's certain places, there's a big print sizes, then they also have provided certain trays to keep the prints. There are so many prints already kept in the wash, so we can put multiple prints in one go in the wash and in the sinter. Sinter, now we have moved to the third section of the printing setup, that is the sinter. We have sinter 2 setup here, which is the biggest sinter that the company has produced till date. Now we will show you how do we open this sinter. This sinter is a big furnace actually. Its temperature can rise up to thousands of degrees. So he's opening the door of the sinter. We have his opening. There is a table for putting this. He'll put it in a table separately. Now he'll show you the sinter, the plate in the center. There is a flat plate on which the material is to be kept. This tool that is holding his hand now is a blacksmith tool. These are blacksmith tongs or blacksmith wrenches, because the temperature of the sinter is too high. So we have to put the gloves on. So these are insulating gloves. Before touching that, we have to put these gloves. The temperature for stainless steel, this stainless steel is for 30 minutes is 1066 degrees centigrade. So this is a stainless steel only. So right now the temperature would rise up to 1066. This is a ceramic plate on which all the sinter parts will be put. The sintering process is too expensive. To in one go sinter, the cost of that maybe to go up to maybe 4,000 rupees or so, depending on, because a lot of gas is consumed. You can see at that back end on the wall, there is there is a gas control panel. In gas control panel, there are certain control valves. You can see certain display dial gauges are there. So those are all controlling the supply of the inert and the mixed gas. When I say inert gas, that is the argon. Inert gas is argon, and the mix is of the argon and hydrogen. So we have to have the cylinder banks. We have 12 cylinders in the line. The mixed cylinders, 2 mixed cylinders of argon and hydrogen, and other all are argon. So now he is putting the plate into the sinter machine. He has put it to the last end, and we have to be very assured, very certain that the position of the components, if the plate is to be removed once again, so however this doesn't happen normally. Suppose if in between the process is to be stopped and due to certain reason, maybe power cut or so, if certain catastrophic failure happens, the position of the printer has always to be the same all the time. Print which are kept there, the 3 components kept, at what dimensions are they kept, at what distance from the end of the plate it is kept, and those will be kept at the same places all the time. Now he is closing the door of the sinter. He completely closes it using this Allen key, because the temperature is too high, so it has to be completely safe for the environment. As I said, the room is air conditioned, the outer environment of the room should not be affected at all. So it is insulated properly so that it can be used in this kind of environment. So what he has put in the sinter is green part. When we will sinter it and we will take out, what we will get is the completely ready part, that is a solid part. There is a size reduction always. When we heat that, it is a contraction in the material. The final dimensions of material is obtained only after this sintering. Suppose if I have a rod of a dia 10 mm and length 50 mm, this 10 mm would be produced as a green part as 12 mm. Generally 20% more size is produced in green. So the final print would be the dimension that we have actually required, that we have put as an input in the software. Now we can show you the display of the sinter. It is right now showing 28 degrees centigrades. The sintering cycle again goes for the hours of the order of 10 to the hours. So he is clicking certain gas and materials. He can do certain options in the menu available: gas and material, utilities, settings, storage, security. In gas and material, he says, yeah, mixed gas, it is already there. Inert gas is already there. Inert gas reserve, he said, yes, it is at this pressure of 21,000 kilopascals. And we have tube runs 10, then we have supply filters left 35, then we have exhaust filter. If they say replace, it only means that the reserved component, reserved part of the cylinder might have to be replaced. However, it has the enough gas to run this sinter run. So next we can go back through this error in the top. Next, utilities, what are available. Do we need to control the gas walls? Do we need to have thermal controls, pressure systems? Then firmware recovery only if suppose some default or maybe rerun of the system is to be done. The certain diagnostic are there. System diagnostic, whether the printer completely the system is running fine or not. Then we have network diagnostic, whether the network is connected to that or not. We'll go back again and show you the other options, like certain settings. We cannot move to all the settings right now. So the certain settings of the pressure, certain errors, if those are there, we need to clear the errors. So many options can be put there. So what is the storage? All these settings. The major point is we already have put their input at the material is this grade of the stainless steel. The sinter will understand that the software is intelligent enough to understand at what temperature would it go. When we switch it on, it will show the time left. The time left, that is the number of hours which are left to finally get the printed part out. It will show you maybe 28 hours are left, depending upon the sintering size and everything, depending upon the maybe 14 hours. So whenever the sinter, it is actually the annealing process. Annealing, if you know, again, we go to the critical temperature, we cool down at a certain rate maybe 2 degrees per hour, 10 degrees per hour, right? Temperature reduction. It is too long process. But just annealing, normalizing, these 2 or 3 processes run and within the sinter setup, and what we obtain from that is a sinter part. Now this sinter part, if you see the part, the base of the part also had a plate. That plate is removed and we get a sinter part completely, with optimal print that we get, with the optimum size that we have put as an input in the software. So this is how the 3D printing setup happens, all the three. Now I would like to show you some 3D printed parts that we have already developed through this setup itself. So there are certain components which are ready. This is a nozzle that is used this is actually model of the nozzle that is used for the impellers in the aerospace industry. So generally to develop this kind of the material, this kind of the component using the conventional machining, it takes a lot of time, and we have to also braze the material from here. It is the top is developed separately, this component is developed separately, then brazing has to happen. We get certain projects from certain agencies like DRDO itself. They want this whole component to be built up, this kind of the components to be built up as a single part. So this kind of things are developed. Also, this is a benchy that is given by Markforged. It gives us certain angles, what are the angles at to which the printer can be used, and certain holes which are made. You can see the Markforged is printed here properly. Then with the Markforged their logo is also printed here. So there are certain components which are printed And I would like to also show you how the plates, you could have seen certain plates were there for all the plates. These are the plates which are the removable material. So this is a missile that is produced. So in this missile, this plate is removed. This is after the complete sintering. So you can see certain marks are there. These are the marks of small attach. Here we had ceramic, which was removed using our wash liquid itself. Now these you can see the small points are there. These are support materials which are all removed. This is the missile. You can also see this part can also be removed. So this part was only a support. This was not required. But to develop this kind of the component at this place, it is being held in the air itself. So we have to support something. So this part is only the support to produce the height of this missile. Right? So these are certain examples that how this is now complete metal. Even if I throw, it will not reveal. This is completely strength, having full strength stainless steel. There are certain tests for that, mechanical engineering tests like impact strength, tensile, compression. All the tests can be done. On certain, papers are also published. Research papers are also publishing this. How do we test? Like what orientation do we have? Have we printed? It is just printed like this only. We have printed in maybe 45 degree to have better orientation. Now it has lesser strength in this direction. If I try to break in this direction, the tensile strength, if I see here, it will be lesser. If I printed in the 45 degree angle, the tensile strength would in this direction would be much higher. So depending upon the size material, this is all engineering, mechanical engineering and the material engineering that you study. This is how the components are produced. The major components, the major steps in 3D printing, metal 3D printing for the Mark Forge, Sinter 2 and Wash 1 setup, we have now demonstrated. For any queries, you're open to come to MedTech IT Kanpur where this printer is installed, and thanks for your time.